In this video, we're going to talk about a ring counter. A ring counter is like a shift register. So in this video tutorial, we're going to talk about 4-bit ring counter. So we can see here we have a ring counter is made of also of flip-flops. So we have flip-flop, let's call it 0, 1, 2, and 3. So what the ring counter does is shifting ones in each flip-flop. So for example, how will ring counter count? It will count, for example, from 8, 4, 2, and 1. And then it will keep repeating. So in that case, it says that the output of the last flip-flop is connected to this flip-flop here. So each flip-flop are connected. So now here we have, for example, if we had 1 here in the first clock, in the second clock we'll have 1 here, and then in the third clock we'll have 1 here. This is Q0 is going to be equal to Q1, and Q1 is equal to Q2, and Q2 is equal to Q3. And then last, since we're going to repeat from 1 to 8, and then we need to connect the last flip-flop to the first flip-flop, which is Q3 is equal to Q0. So in this case, this is a synchronized counter. So we're going to have a clock as our input. So we have a clock, and it's connected to each flip-flop. And then we will have our controller, which we're going to name it start. So this it will initialize the flip-flop when we want to start, and we need to start on either 1, 2, 4, 8. So for example, let's look at a scenario if we have the first clock. So we will have a clock here, and then this is rising edge, and we have a start, and we have Q3, Q2, Q1, and Q0. So at the beginning, at 0 o'clock, we want to set our start to be high 1. So for example, we'll initialize the flip-flop to this number 0, 0, 0, 1. So we'll be here. So we'll say that this is going to be 1, and then it's going to be 0, 0, 0. And then in the second clock, this need to be 0, and then we will see that this 1 will become here. So we're going to have 1, 0, 0, 0, and then in the second clock we must have this to be 0, and then you see that it's going to be a ring counter. So this one's going to be 0, 1, 0, 0, and then the third clock we need to have 0 again, and then we're going to have 0, 0, 1, 0, and then in our last clock, so this is going to be 0, and then we have 0, 0, 0, 1. So this is kind of idea how we want our ring counter to perform. So the only start we will have at the beginning to initialize our counter, and then the counter will count from 1, 8, 4, 2, 1. If we're going to have the next clock here, let's just call clock 5. It will repeat again from 8. So in other way, we can say our ring counter only have these states here, which is equal to 4 state, and then it is equal to number of flip-flops. So let's design this on the Verilog file and simulate it on Model Sim to see how it works.